All right, we're going to talk now about bypass caps. But before we do that, we have one more important thing to look at that's also involved with libraries and your components. I want to show you one of the gotchas that happens all the time in Altium here. I'm going to go to components and I'm going to open up the miscellaneous devices here. Let's see where we're at. There we go, miscellaneous devices. And I'm going to look at the resistors here. There's one called R pot or potentiometer. I'm going to double click that and just place it here. And then I'm going to change libraries. We'll go to the, let's see, we got the ECE library. And I'll grab a potentiometer out of here. And I'll put it here. Now if I take this pot, I can right click and say show me the properties. Oops, there we go. I'm going to lock that in place. This little thumb tab here looks like a thumbtack that you push in a board. If I push it here, it locks that in place and stays there. So I'm going to come here, I'm going to look at this guy, I'm going to say show me what he looks like. There's what his footprint looks like. The footprint's going to be what it physically looks like on your printed circuit board. Right? Not the schematic symbol, but what it looks like in real life. I can go to this guy and do the same thing. What does he look like? Oh, okay, look at that. There he is, kind of the same footprint. Let's look at the pins. So the pin number on this one, I have pin 1 as the top, pin 2 is the bottom, and pin 3 is the tap. Now, in all my years in this business, and I've been at it a long time, I've never in my entire career seen a potentiometer that had the wiper pin on the end. I don't know why they did that. Let's look at this guy. If we bring him here, let's see. Oh, he also has pin 3. Look at that, pin 3 on the tap. That can be a problem, right? Don't get caught with this because the wiper or the tap is always in the middle on these pots. If you make your board like that, you're going to have to twist the leads, maybe cut traces. Let's go back to our components. Let's find another pot that doesn't have that problem. Let's see. I'm going to place this pot. And I'm going to say, show me the properties here. So this guy has a different footprint. There's the 3 pins. The 3 pins are at the edge of the device, not shoved in the middle, not offset. And when I look here, I have pin 1 at the top. Pin 2 is the tap. That's the way all the potentiometers are that we use. And pin 3 is at the bottom. So that makes a lot of sense. I can see that now and know that that's correct. If we want to see the pin numbers, I can unlock this here and say, show me the pins. Make them visible. There's pin 1, 2, and 3. If I go to this guy, I can do the same thing. Show me the pin numbers. Look, pin 2's down here. That's a problem. And this happens every semester. People make a mistake and they'll forget. And they'll place the pot out of the miscellaneous devices, and then when they wire it up, it's not wired correctly because pin 2 and pin 3 are swapped. So keep that in mind. All right, I'm going to come here. I'm going to highlight all 3 at the same time, drawing a box around them. I'm going to hit delete. Gone. I got that out of my project because I don't need them there. Now let's talk about our bypass caps. Bypass caps can be very important in our project. One thing I have no control over in my project, when I make this little op-amp board, I have no idea where the power's coming from. Is it a power supply that's this far away? Right there, I got power. Or is it coming from a long cable going all the way down to the wall and across the room to a power supply over there? Maybe it's on a Humvee out there in a military vehicle and I got 25 feet of wire and it's picking up noise. I have DC resistance, I have inductance, right? So I don't know what's going on here. Because of that, I want to make sure that I have a nice, clean power supply. So let's come up here. I'll just go back to my miscellaneous devices here, and I'm going to pick a capacitor. There's a cap. I'll double click on that. Now you see that while it's attached to my mouse, it says 100 picofarads. If I place that cap, I can always come here like we did with the resistors and change it to 100 nanofarads if I want to, and do that every single time I place a cap, but that's going to take some time, right? Part of engineering is efficiency. So I'm going to come back over here and double click and say I want to place this cap, but before I place it, I hit my tab key. Now the properties of that cap show up. Here it says 100 picofarads. So I'll come over here and I'll change it to nanofarads. I'll unpause it. Now I have 100 nanofarads here. I'll attach one here and attach one. Whoop, I missed, but that's okay. We can move it. I'm going to rotate. Let's see. I bet I'm going to want to move that whole thing up. So let's do this. I'll probably want to do the same down here. So I just placed 4 caps, and when I did, they're all 100 nanofarads. I don't have to go back and edit them now. So I want to move my power rail up here and move this power rail down. Why am I doing that? It makes it easier to wire and easier to deal with my schematic and read it without these things being over the top. This text would have been down in here, hard to read. So I'll put grounds here and a ground here. Up here, I can just wire it to ground. All right, I have ground there. Now this cap I want to move over, and I'll wire him. So he's wired in. See the little red squiggly lines there again? Altium's trying to warn me, you got a problem. And what's the problem? I have 4 caps that haven't been annotated. They're all the same. If I left it that way, it would assume that this net and this net are connected, and this net and this net, they're all shorted together. It'd be a real problem. So let's go to Tools, Annotation, Annotate Quietly, 4 designators, go. Now I have C1, C2, right, C3, and C4. Perfect. They're all annotated. And you might wonder, why do I have a cap here and then another cap here? I put them in parallel, right? Plus 9 volts, 100 nanofarads, plus 9 volts, 100 nanofarads. Well, this cap I put next to the power input to help clean up the power supply right where it comes in. This cap I will solder on my PCB right next to this chip, because I don't know when my board gets routed, that wire could be really long. Let's see if I can draw on the screen here. I might have a wire here, and the wire might go all the way around and up here and down there until it finally makes its way around and connects here. When that happens, I now have a long lead that has resistance, has inductance. I could have noise coming into my little op amp there, and I don't want that. So what I can do instead is put a cap right here, and I want the cap right next to it. The other thing is, this amp might be switching very fast, and it could be causing some little noise pulses because of the resistance and inductance on the line. So I'm trying to clean it up on both sides. Now this little cap is made out of ceramic, and just imagine that I had a device. I know it's my phone, but let's pretend that this is ceramic, and I have a plate on this side and a plate on this side. So now I have 2 plates separated by ceramic. That makes a capacitor. The ceramic capacitors are nice because they're small, they're fast, and they're inexpensive. So I can put 100 nanofarads here, and it can respond very quickly to noise. And same thing here. What it's not good at is having a lot of capacitance, right? This isn't 100 microfarads, it's 100 nanofarads. So what I'm going to do now is place 2 more parts. I'm going to come back up here and say I want a polarized cap. I'm going to hit tab, because it's not 100 picofarads. It's going to be 100 microfarads. There we go. So now it says 100 microfarads. I have my nice polarized cap. See where it has a plus symbol on there? It has a plus symbol because it is polarized. It wants that lead on the top to be more positive than the lead on the bottom. So if I take my cap here, I can place it there. I'll be able to wire that in. When I place one over here, I don't want to place it like this because the lead at the top will be more negative than the lead at the bottom. So I'll rotate it and place it right there. Now I can wire those in. And I'll put these polarized caps, and I'm going to talk a little bit about the differences in those polarized caps. Same problem, C question mark, C question mark. I need to come up here and annotate my schematic so I don't have a problem. There we go. Now I have 100 nanofarads, 100 microfarads, 100 nanofarads, 100 microfarads. I look at them like, okay, so caps in parallel add. I went from 100 to 100.1. What's my advantage? Well, the advantage for this cap is it's large, so it can hold a fair amount of charge. So if my power supply dips slowly and comes back up, this cap right here can help filter that out. He can hold a lot of charge. With the little ceramic cap, if my power supply gets a spike, this big cap can't react that fast, but this little cap can. So when I put those two caps together, there's my advantage. I'm getting high frequency noise reduction and low frequency noise reduction at the same time. Now those big caps, they're made out of aluminum and they look like a little can, right? You look at it and I just use this roll of tape, right? It looks like a can. Inside, it's a lot like this roll of tape. It's going to be layers of aluminum. They'll have a long thin strip of aluminum with a long thin strip of insulator, it's like paper, and another long thin strip of aluminum. So now you have those two long thin strips. Nobody would want a capacitor that's 7 feet long sitting on top of their board. So they take that just like this tape and they roll it up. They roll it up. So now you have that 7 feet or whatever it is all rolled into this tight little can. That gives me a lot of surface area, so I get a lot of capacitance. But that long, thin strip has resistance and inductance. It slows it down a little bit. That's why electrolytic caps are a little bit slower. Putting the two together, though, I have a big advantage. Now I have high-speed reaction, low-speed reaction. I have a fair amount of capacitance to help me. If my leads on my PCB are a little bit longer, that'll be okay because I have a bypass cap over here too to get rid of the high frequency noise on this side. Alright, so that probably is about all we need to say about bypass caps. Just remember in all your designs, you want a 0.1 microfarad on every active chip right on the VCC pin. That's true like with your Pi Pico. If there's more than one VCC pin, I want to put a 0.1 microfarad on every VCC pin. And ground, if you have more than one ground on your chip, you want to hook every single pin to ground that says ground on your chip. Don't just look at it and say, oh, there's ground on pin 27, I'll hook that one up, the rest of them are okay. You want grounds on all of them. You want VCCs on every VCC pin, and you want a cap on every VCC pin, that 0.1 microfarad right next to that pin on your PCB. All right, don't forget these things. These are important.